Hi, today we learn about multiplication theorem on probability, especially conditional probability of dependent events and conditional probability of independent events. Some question based on this concept. Suppose the question is a bag contains 5 red and 3 black cubes. You have a bag, 3 black and 5 red cubes. 2 cubes are drawn at random without replacement. So, without replacement. So, 1 cube we are withdrawing and again one more you are withdrawing. Then find the probability that both cubes are red. This is what you want to find out. Now, this question, suppose I am marking as first is red, or we have a red and black. So another possibility is non-red, is not red, that means black. These are the two possibilities. I'll take as black. This is black. So red or black. So this is the case 1. First we are taking that one. 1 cube from this bag. It can be red or it can be black. Now, what is the probability of getting this is a red? So, probability of red is here you can see that there are 5 reds out of 8 cubes. So, 5 by 8. Now, again you can see here black is you have a 3 black. So, we will get it probability of black is 3 by 8. So, first choice is over that. We are taken 1 cube is outside. Now again we are taking that second cube from this. It's a without replacement. So, 1 is already removed from this. It can be red or it can be black. Now second case is, it can be, this is red, again second is happening as a red. But first is what? R1. That is, first is red is happened. What is the possibility of the second also red? Or is possible that first is red is getting, what is the probability of getting black? First is here red actually. So it is coming red. Then what is the probability of getting black? Or from here is happened that one first case it is happened that black. Now possibility is what? 1 is red or other is black. Now R1 is happened, that means first draw 1 red ball is we have taken outside. So here total red ball is now what? 4 red balls. So from 4 red balls we have to take second red ball. So that will be probability of R2 given R1 is equal to, it is 4 red ball because 1 red ball already we have taken. So 4 by 7 because total 8, 1 already is taken, second one is 4 by 7. Similarly here what is probability of black given red one? First draw we are taking 1 red, then what is the probability of getting black? Black how many are there? 3. Only red we have took in first, so it's 3 itself. But the total is 7 because 1 out of 8 ball, 1 already we took red. So 3 by 7. This is your conditional probability. Black, probability of black given R1. Now here it is what? Probability of R given B. So black is happened. So one black is gone. Then what is the probability of getting red? Red is how many are there? 5 is there. But how many total? 7. Now here probability of getting second is black. First already is what? Black. This is already is here black. Then first also, second also is a black. So B1 given B2 given B1. B1 happened, then what is the probability of B2? So here it will be what? B1 happened. So one black ball is gone already in first case. Then is 2 is left over divided by total is coming 7. Now the question is find the probability that both cubes are red. Now both are red is happening means where? R1 this is both red. Here red and black. Here black and red. Here black and black. So both are red. So probability of R1 first row, that is here one black ball, red ball. Second also red ball. So R1 intersection R2, that is coming. First is red one. What is the probability? So probability of R1 into probability of R1 happened already. Then what is the second also? Red ball. So this equal to 5 by 8 into this is 4 by 7. So this 4 2 times. So 5 divided by 40. So here probability of both getting red cube is, first one is red 5 by 8, second is probability is 4 by 7. So 5 by 8 into 4 by 7. This will call as the multiplication theorem on probability. Multiplication theorem on probability. Now see that in conditional probability we have learned that probability of A given B means probability of A intersection B divided by probability of B, and probability of B should be not equal to 0. Or we have seen that probability of B given A means probability of A intersection B divided by probability of A. Probability of A is not equal to 0. Division by 0 not defined. So from this definition of conditional probability, we can take as probability of A intersection B equal to probability of B into probability of A given B. And from here we can see that probability of A intersection B I can write as probability of A into probability of B given A. So this you can see that in first row, if it is happened red, then what is the probability of get red in second? So whatever is happening in first case is affecting the probability of the second case. So we will say that these both are dependent events. So this we will say as conditional probability of dependent events. Dependent events. First row or first case, what is happening that will be affect the probability of the second event. So it is dependent events. So here again we have seen that it is without replacement. This is also very important word, without replacement. So without replacement, it is will come what? It is dependent events. Now suppose I am taking that generally one event as A. So other is complement of A, that is A complement. Red and black. So red non-black or A complement. So here again you can see that if A is happened, what is the probability of B? Similarly, A is happened, what is the probability of B complement? Similarly, here also probability B given A complement. A complement is happened, then what is the probability of B? Again we can see that probability of A complement is happened, then what is the probability of B complement? So from this we can say that probability of A intersection B equal to probability of A into probability of B given A. You can see here is probability of A is happening. This is probability of A complement. So probability of A into probability of B given A. So here is probability of A into probability of B given A. So probability of A intersection B complement equal to probability of A into probability of B complement given A. Similarly, third is A complement intersection B, that is probability of A complement into probability of B given A complement. Fourth, probability of A complement intersection B complement equal to probability of A complement into probability of B given A complement. So these are the multiplication theorem of dependent events, or we can say that conditional probability of dependent events. So next question, a bag contains 5 red and 3 black cubes. 2 cubes are drawn at random without replacement. Find the probability that at least one is black. At least one is black. So here you see again that when you are taking that picture, tree diagram, so first is happening that one red, then second one is probability of red given red, second also red. If you want, you can mark the red one, this is red 2, red 1, or this is black, then here is again black given red, second one. So here again red given B, or probability of given B black. These are the possibility. We have already marked in previous case. So here it is red, first red is coming means 5 by probability of R1 is coming 5 by 8. So first is red happen, then what is the probability of second also red? So one red is already gone, so 4 red is the total board cubes is 7. Similarly here it is black, so total is 7 only, So total black cube is 3. So 3 by 7. Here is coming, probability of black is coming first case, 3 black out of 5. So black is happened, what is the probability of get red? 5 red is there, so 5 by 7. Then first is black, then what is the probability of getting second also black? So first black, 1 black is gone, remaining only 2 blacks, so 2 by 7. Now they are asking 2 cubes are drawn without a replacement, again without a replacement. So it is dependent events, that is why we are getting 5 by 8, one is not replaced, so 7 only it is happening. Total cubes is 7, decreasing from 8 to 7. Now find the probability that at least one is black. Now see, here both are red, both R1, R2, both are. Here red and black. So one is this, at least one red, at least one is black. So one black, so black and red, here also one. So one, at least one is black. That means what? 2 also can be black. So 2 black is, this is also. So these are the 3 possibility case from the tree diagram. Now see, you want to get for that at least one is black. So we want to find out what is probability of black. So here is see that one is this case, red and black. So 5 by 8 into 3 by 7 plus again black and red. So 5 by 3 by 5 into 5 by 7 plus 3 by 5 into 2 by 7. So this is equal to 15 by 56 plus 15 by, so 3 by 8. So 15 by 56 plus 3 into 2, 6 divided by 56. So this is equal to 50, 50, 30, 36 by 56. So you can see that 4 is common. So 9 into 4, 36. So 14 into 4. So 9 by 14. Now see here, we have considered that one case, second case, third case. We know that all this total sum of the probability will be what? 1 only. Except this is 1 black, in this both 1 black, this both black. So what we want to get it that one, instead of doing like this, I can do as probability of black, at least 1 black means we can immediately write it as 1 minus probability of both getting red. So this we can write it as 1 minus probability of red 1 into probability of red 1 happen, then what is the probability of second also red 2. So 1 minus probability of red 1 is 5 by 8 into this is 4 by 7. So 1 minus 24 2 times, so 5 by 14. 14 minus 5, that is 9 by 14. See, you got a same answer that. So we can do like this also. Now one more important thing is here, picking up same number of objects, 1 by 1 without replacement. is equivalent to simultaneously picking up a number of objects. That means here we have taken that both red ball. Okay. So instead of first case we are taking that one red ball, and second case we are doing again second ball. So picking one red ball first, then without replacing second row. Instead of doing that, if we took both ball together, I am taking that one is both cubes are taking together simultaneously. I am withdrawing that both cubes. Then immediately you can write this as, or probability of B equal to 1 minus, you have how many balls here? You want both is red. How many reds are there? 5 reds. So I can take from 5 2 balls together. I am taking simultaneously. Same time, see total balls, how many are there? 8. From 8 only we are taking that one. So 8C2. I am picking 2 cubes from 8 cubes. This is your total case. And we have 5 cubes. So we are taking 2 cubes together. So that is what I told, that picking up same number of objects one by one without a replacement is equivalent to simultaneously picking up a number of objects. So here I am picking both the red ball together. So this you simplify and see what is happening. 1 minus 5C2 means 5 into 4 divided by 1 into 2 divided by 8C2 means 8 into 7 divided by 1 into 2. So 1 minus 5 into 4 divided by 8 into 7. So 4 2 times. So 1 minus 5 by 14, that is equal to 9 by 14. So you got it again, same answer. So whenever we are taking without replacement, that word is happening, we can use the combination concept to find out the probability. So here now this question you see here, a bag contains 4 red, you have 4 red, 3 blue and 2 white. If 3 balls are drawn one by one without replacement, one by one without replacement, that means it is dependent events. So here again that, then what is the probability? All 3 balls are red. So first red, second row again red, third also red. So all 3 cases it is happened to red. I am not marking all other things, no need to write that also. Now here is the first case, red means how many reds we have? 4 reds. So probability of R1 equal to 4 by, total is how many? 4 into 3, 7 plus 2, 9. Now one red is gone. Then probability of R2 given R1. R1 happened, then what is the probability? Second ball is taking red only. So one red is gone. How many red is remaining? 3. So you have 3 reds. Total ball instead of 9 is become what? 8, because 1 is already taken out. Now 2 ball is gone. Now how many red ball you have? 2 red ball. So 2 red ball, R3 means 2 red balls. How many total? 2 balls gone out of 9, so 7. So this is will be here probability of R3. This both has to happen. So R1 intersection R2. So we want to find out all 3 balls are red. R1 intersection R2 intersection R3. So 4 by 9 first, second is 3 by 8, third is 2 by 7. So 4 into 2, 8, cancel, 3, 1 divided by 7 into 3, 21. So we can say that generally probability of A intersection B intersection C. See that multiplication theorem, we are doing extension that. Previously we had done is A intersection B means what? Probability of A into probability of B given A. So here A intersection B intersection, probability of A, see probability of R1. Second one, A is happened, then what is the probability of B? Second one, R2 given R1, B given A. Now third is what? A and B happened, this means. That means R1 and R2 happened, then R3 has to come. So third is C. What is happened? This A and B should happen. So A intersection B. So this will call as extension of multiplication theorem. If you want to see, we can generalize this one. Probability of A1 intersection, A2 intersection, etc. AN equal to probability of A1 into probability of A2 given A1 into probability of A3 given A1 intersection A2, etc. Probability of AN given A1 intersection A2, etc. intersection A n minus 1 less. So here is the 3 means up to 2, 2 means 1, like that. So n means n minus 1. So this will call as extension of multiplication theorem. Now see, you see this question. A bag contains 5 red and 3 black cubes. 2 cubes are drawn at random with the replacement. So with the replacement we are taking. Find the probability that both cubes are red. Previously we had done the same question but without replacement. So it was a conditional probability of dependent events. Now we will see what will happen here. So you have 5 red, again 3 black. So 2 cases happening. First case, second case. First cube if we are taking, one is red, then again is red or black. Then first case black, then again red or black. Now here probability of R1, first is red. What is the probability of getting R? That is happening what? Probability of getting first R or R1. That is 5 by 8. Now this again we are keeping back that ball, red cube is we are keeping back with the replacement. So total ball is again red 5 will be there, and again 8 total ball will be 8. So this will be probability of again 5 by 8 only. But here it is, see, R1 is happened, then again is R1. So here, the previous case we have written probability of R2 given R1. R1 is first ball is red, then what is second ball also red. Here first red happened, we are keeping back. So your probability is not changing. So probability of R2 given R1 become is probability of R2 itself. It's not affecting the probability. What is happening in the first case is not affecting in the second case of probability. So here it is coming what? 3 by 8. Probability of black. Again here it is what? Probability of first case is R1 happened, then what is the probability of black? Again R1 happened, so one red ball is taken. You are keeping back that red ball. So you have a totally same again 3 black. So here probability become 3 by 8 again. No change. Previous case we are not keeping back, so it's become 3 by 7. But here it is keeping back, replacing, so 3 by 8. So here black 3 by 8. So red is coming again 5 by 8. So here also 3 by again black is coming means replacing, so 3 by 8. So you want to find out both cubes are red. So probability of both cubes are red. R1 intersection again R2. So here you see this is red. This is only one case is coming, both are red. See, red, red. This is red, black, black, red, black, black. So R1 intersection R2 is equal to probability of, that means first one 5 by 8 into 5 by 8. That is 25 by 30, 64. Now, here we can say that probability of conditional probability independent event. That means with the replacement. With the replacement. See, here already we are keeping back, so it's not affecting that. So we'll say that one conditional probability of independent events, or we'll say with the replacement. If this word is coming means immediately we can say that one is probability of A, then probability of A complement, again probability of A. That means we are taking another event B, probability of B again, that means B complement, then probability of B, probability of B complement. So you can see that probability of A intersection B equal to probability of A into probability of B. From here, first one. And probability of A intersection B complement equal to probability of A into probability of B complement. Probability of A complement intersection B equal to probability of A complement into probability of B. Probability of A complement intersection B complement equal to probability of A dash into probability of B dash. So here we will say that A and B are definition. If A, B are independent events associated random experiment, then probability of A intersection B equal to probability of A into probability of B. So this is your multiplication theorem of independent events, and other one we have learned that multiplication theorem of dependent events. So it is affecting the probability. Now here one conditional probability of dependent events. The other one is conditional probability of independent events. Here without replacement. Here with replacement. Here you can use combination. Can't use. Combination. So here probability of A intersection B means probability of A into probability of B given A. Probability of A intersection B complement equal to probability of A into probability of B complement given A. Probability of A complement intersection B complement equal to probability of A complement probability of A complement into probability of B given A complement. Probability of A complement intersection B complement equal to probability of A complement into probability of B complement given A. Here probability of A intersection B equal to probability of A into probability of B. Here again extension of we have seen A intersection B intersection C equal to probability of A into probability of B given A into probability of C given A intersection B. Here generally we can say that A intersection B intersection C equal to probability of A into probability of B into probability of C. So independent events. These are the main concepts. If A and B are independent, then A complement and B are independent. A, B complement are independent. A complement and B complement are independent. That means probability of A intersection B equal to probability of A into probability of B. Then probability of A complement intersection B equal to probability of A complement into probability of B. Probability of A intersection B complement equal to probability of A into probability of B complement. Again probability of A complement intersection B complement equal to probability of A into A complement into probability of B complement. Now see the question. Probability of A is 1 by 4. Probability of B is half. Probability of E into find probability of A given bar given B bar. That is A complement given B complement. Definition is A complement intersection B complement divided by probability of B complement. This is the definition of the conditional probability. Now here probability of A is 1 by 4 is given. Probability of B is given 1 by 2. So probability of A into probability of B equal to 1 by 4 into 1 by 2 is equal to 1 by 2 is equal to probability of A intersection. That means probability of A intersection B equal to probability of A and B. Therefore, A, B are independent. That means what? A dash B dash also independent. So I can write immediately A dash into probability of B dash divided by probability of B dash. Since A dash B dash are independent. So this is cancelled. Probability of A dash, that is 1 minus probability of A. So that is equal to 1 minus 1 by 4. That is 3 by 4. Now here it is A and B are two independent events. Probability of A union B is given. So A and B are two independents means probability of A intersection B equal to probability of A into probability of B. This is given. Now probability of A union B is given as 0.60. A union B means probability of A plus probability of B minus probability of A intersection B. Now this is A plus B minus this we can take as probability of A into probability of B. Therefore, probability of A plus probability of B is common, 1 minus probability of A. That is equal to 0.60. So here you want to find out probability of B. Probability of A is given at 0.2 plus probability of B into 1 minus 0.2 equal to 0.60. So therefore probability of B equal to 0.60 minus 0.20, that is 0.40 divided by 1 minus 0.2, so that is 0.8. So this equal to 4 by 8, that is equal to 1 by 2. Next question. Probability of A is given, probability of B is given, probability of A intersection B is given. Check just you want A bar given B bar. Definition again A complement given B complement equal to probability of A complement intersection B complement divided by probability of B complement. Now here is C. If you multiply 3 by 8 into 1 by 2, that is 3 by 16, not equal to 1 by 4. So this is not independent. It's a dependent. So we can't apply that property here. Now see here, we know De Morgan's law that probability of A complement intersection B complement means probability of A union B complement. A union B complement equal to A complement intersection B complement. De Morgan's law. So this equal to 1 minus probability of A union B. Complement means 1 minus probability of that event. So 1 minus A union B means probability of A plus probability of B minus probability of A intersection B. So 1 minus probability of A is 3 by 8 plus 1 by 2 minus 1 by 4. So 1 minus here 8, then 3, 2 4 times 4 minus 4 2 times 2. So 1 minus 3 plus 4 7 minus 2 5 by 8. 8 minus 5 3 by 8.